In this video, I'm going to tell you about a procedure called broadcasting in Python. Broadcasting is something that you will use very often when you're working with data matrices or data analysis, anything with linear algebra, anything where you're working with matrices and vectors. It's pretty likely that you are going to need to use something called broadcasting. Now, if you are coming to Python from MATLAB, if you have a MATLAB experience, then you might be familiar with what's called binary expansion or replicating matrices. That would be something like BSX_fun, so functions like BSX_fun, or multiplying matrices and vectors using repmat. That would be the MATLAB version of broadcasting. Anyway, let's see. So for this video, we need numpy. So we import that. And by the way, if you ever notice that Python starts indexing at 0, but they actually know that human beings start counting at 1. You know, this was the first cell of code that I ran, and this isn't the 0th cell of code. This is the 1th cell of code. But anyway, we'll leave that as a little tidbit to think about. Okay, so what I'm going to do is set up a matrix. So I'm going to create a numpy array. And let's see, this is going to be just a simple matrix here. I'll have the first row be 1, 2, 3, and then 2, 3, 4, and let's see, the next row will be 3, 4, 5. Can you guess what the next row is going to be? I'm sure you guessed it. It's going to be 4, 5, 6, and I think I will stop there. So this is a 4 by 3 matrix. Remember, when referring to matrix sizes, we always talk about first the number of rows and then the number of columns. So this is a 4 by 3 matrix. We can confirm this by saying x.shape. Shape is a method on a numpy array, and that's going to return 4, 3. So we have 4 rows and 3 columns. Of course, if we just wanted to know the number of rows, we could just request the first output of the first element of this result, and that's going to be 4. Okay, anyway, so here is our matrix, and then I'm going to specify a vector. Let's call that 10, 20, 30. Okay, so what I want to do now is add this row to each of these rows. So I want to create a new matrix where the first row is going to be 11, 22, 33, and then the second row is going to be 12, 23, and 34, and so on. So you get the idea. So the question is, how do we add this vector to this matrix 4 times? So we want to add it to each row separately. If you would like to pause the video and have a go at that, then go for it. Now, this is something we would do with broadcasting. You don't have to do it with broadcasting now. In fact, I'm going to start by doing this in a for loop to motivate the advantage of broadcasting. So I hope you paused the video and had a go at this. I'm going to create a new matrix called y, set it equal to x, and then we're going to basically loop over the different rows. So for I in range, and we want to go over the range of the number of rows. So I already showed you that was x.shape 0. And then what we're going to do is say that the ith row in y is equal to the, oops, this is supposed to say the ith row, not the ith column, is equal to the ith row in x plus w. So that's it. It's actually, oops, no, plus w. So that is pretty straightforward. Let's print these out. So I'm going to print out y, and then with a little bit of space just for ease of visual interpretation. And then I'll print out the original matrix x. Okay, so we see that y looks great. This is exactly what we wanted to do. We have taken this vector, this 3-element vector, this row vector, and added it to each individual row of x. And that gives us this new vector, or new matrix y. However, when we print out x, you can see we've also changed x. Now, this might be intuitively very strange, and if you're coming from other programming languages, it might also seem very strange. We didn't actually change x at all. We changed y, and we never changed x, but it looks like x changed all on its own. So this is one way that it's a little quirk of Python, but important to know. When you set some variable equal to some other variable, you're not actually creating a new version of this matrix and putting it into another variable called y. Instead, you're just creating two different pointers to the same object in Python's memory buffer. So x and y are just different ways of referring to exactly the same thing. It would be like, you can call me Mike or you can call me Michael. Those are technically different. Mike is not the same thing as Michael, but they are referring to exactly the same object, which is me. So, or anyone else named Michael. So what we want to do here is create a version of x. We want to create a copy of x that is separate from x. So the way that we can do this is by importing another library called copy. So we're going to say import copy. And most people just leave this as copy, so you don't need to have a alias here like this. So import copy, and then I write y equals copy.deep copy and x. And now what happens is that y is a new variable. It has nothing to do with x anymore in terms of memory allocation and what these things are pointing to on memory. I know this is a little weird at first, but that's just how it is. So you just have to keep that in mind and get used to it. Okay, so now I'm going to try again, running all this code. And now we see that x hasn't changed and we get a new y. Okay, so now let's see if we can repeat this operation without using a for loop. And that's basically what broadcasting allows us to do. So broadcasting sounds like a really fancy term, but it's actually really, really simple. You just say y equals x plus w, and it's just that simple. And then I'm going to print this out here. And then we see that this accomplishes the same thing. Now, if you are new to coding, but not new to linear algebra, this might hurt your brain because essentially what we are doing is adding a vector to a matrix. And technically that's not allowed in linear algebra. This is an illegal operation in linear algebra because the sizes of these two matrices are not consistent for addition. So Python will look at the sizes of these things and basically guess what you're trying to accomplish. And it does that by looking at the relative sizes. So we have 4 by 3 and a 3 element list or array. So Python is going to apply this array according to this operation to each element of 3. And it's not just about addition, by the way. We can also do this with subtraction. You can do this with multiplication. You can do this with division. Of course, this is going to give problems if there are zeros in W, but the point is that Python will figure out the broadcasting and expand the vector accordingly to repeat this into a matrix and operate and implement this element-wise operation as necessary according to the sizes. All right, so that was for W and X. Now I'm going to try something else. I'm going to try setting a vector V, and let's say V equal, actually, first I just want to also show you that this can work for lists as long as the lists are correct. So I'm going to say now X times W. And now what we get is basically the same thing that we would have expected up here. The numbers are different. I just wanted to show you that this also works. Broadcasting also works for a list, not necessarily for a numpy array. However, let's imagine we want to do something else. Now, instead of applying this vector and element multiplying this vector by the rows of the matrix, not row-wise, but column-wise. So we had our original matrix X, which was this. So now imagine we want to multiply down the columns instead of over the rows. Now there's 3 elements in each row, so that makes sense. And there's 4 elements in each column. So let's try doing this. The question is Python going to figure out that now I want to multiply each element in the columns by each element in W. In other words, the result of this equation should be -1 times 1, which is -1, and then this should be 0, this should be 3, and this should be 0, because 4 is multiplying the 0. Okay, so let's try it. And we get an error. So operands cannot be broadcast together with shape. So what we actually need to do here is make sure that this is actually a full numpy matrix instead of being an orientation list or an array. So let's build up to this. So now I'm going to convert this into a numpy array, and we see that that doesn't work. So it still doesn't help us. What we need to do actually is get an orientation into this array. So I'm going to specify that the number of dimensions, the minimum number of dimensions, must be equal to 2. So then we have, see, this doesn't have an orientation. So what I want is for this to be a 4x1 column vector. So now let's try that again. Now it's a 4x1 column. Ooh, actually no, look at this. Python made this a row vector, and maybe I should have foreseen that because this is already a row vector here. So now let's try transposing this. All right, now this actually works. Now we get the matrix. The easiest way to see this is that every other element in the columns is 0, corresponding to these. And then the first row is all ones, and the last, or the third row is are the original matrix elements here. So it's a little bit confusing. You might think that if Python is clever enough to figure this out, then it should also be clever enough to figure this out. But this is just basically how it has to work. So in the beginning of this video, I showed you that broadcasting is really straightforward. It's really simple. And it's also pretty flexible for the data type, the variable type. So it can be based on lists or based on numpy arrays. And that is true in some cases when you're working with the rows. When you're working with columns or other dimensions of a multidimensional matrix, it often takes a little bit more finagling to get it to work correctly. So when you're using broadcasting, always make sure to test first on a small, simple example like this before applying it to a much larger piece of code. This is particularly important if you want to work with a square matrix. You know, imagine X were a square matrix. If you weren't looking at the output of it, you wouldn't actually know whether this broadcasting was being done row-wise or column-wise. Okay, so that brings me to the exercise. And your exercise is to reproduce these 4 matrices. And I'm not giving you code, of course, that's your job, but I'm going to show you the output here so you can see what it is I'm looking for. So there's 4 steps to this exercise. First, you want to create a list of integers from 0 to 8. And the V here means I'm going to call this variable V, lowercase v. You can name it whatever you want. So integers from 0 to 8, that one's pretty straightforward. And then you want to reshape from this vector, this 9-element vector, into a 3x3 matrix. And you can call that matrix M. And that you see here. So notice it's row-wise. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we've transformed this. And in a moment, I'm going to give you a little tip if you need a hint for this part. And then you want to repeat that matrix so it becomes a 3x9 matrix. And I'm going to call that C. And that's what you see here. So notice this matrix looks like a big, conglomeration of numbers, but in fact, this is the same matrix that we have here repeated 3 times. So 0, 1, 2, 3, 4, 5, 6, 7, 8 that you see here. And then that literally just repeats. So I'm just taking exactly this matrix and vertically stacking it 3 times. So here's the first time, the second time, and the third time. Okay, and then finally, you want to broadcast multiply the columns of this matrix C by the elements in this matrix, which we called V. And then I'll call that matrix B. And that's what you see the final result here. So this is, so let's see, this row here is this first row times 0. And then the second row here is the second row times 1. The third row of this matrix is the third row of matrix C times 2, and so on. So that's the row perspective. You can also look at this column-wise and say that this first column here of this final matrix is this column multiplied by 0, 1, 2, 3, 4, 5, 6, 7, 8. So we see 6 times 8 is 48. That's the last one. And so on. The second column is this second column multiplied by this vector, and so on. Obviously, you're supposed to do step 4 using broadcasting and not using for loops. Okay, so I hope that's enough information. good luck working through this assignment. If you need a hint, I am going to tell you in a moment 2 functions that you can use that will help you solve this problem. If you don't want a hint, now is your last opportunity to pause the video. Okay, so here is one hint. For step 2, you can use the function numpy.reshape. So I'm not telling you how to use this function, but this is a function that you can use to solve that problem. And here for step 3, you can use a function called numpy.tile. Again, I'm not going to tell you how to use that function. This is just a function that you can use to solve this problem. All right, very good. Now I am going to work through my solution here. All right, so let's see. I'm going to start by creating this vector v. I'm going to specify this to be numpy.arange, and I want to go from 0 to 9 exclusive, so it actually goes up to 8. This is an exclusive upper bound. So I write 0 to 9, and actually if you're starting from 0, then it's not necessary. Sometimes it's still nice to leave it in just to make it super crystal clear that you're starting from 0, but it's technically not necessary. Okay, so then I'm going to print out v and then print out a space just to give us some separation between these problems here. All right, first part worked. And I guess maybe I could have done this in another cell, but that's okay. Anyway, now we want to reshape this into a 3x3 matrix. So I am using the function numpy.reshape. I'll call this matrix M. So M equals numpy.reshape. And this is going to be vector v. And I want the new shape to be 3x3. So let's see what happens when I run that. And I'm just going to paste out v here. Okay, so what happens when I run this code is we get an error, and the error message says non-string object detected for array ordering. Now, this may seem really weird, and so let's look at the help file here. So the help file says that the first input is the original vector or matrix, and the second input is the new shape. And then the third input is the order. So the order refers to whether it gets reshaped column-wise or row-wise. And so we need the entire shape of the new array to be in the second input. So we just need to put parentheses around here to give us a tuple. Now, the reason why I did that error on purpose is just to show you how to go about problem solving when you are encountering these kinds of errors. It's very easy. You get errors like that all the time. Okay, so this is looking good. We're getting somewhere here. Okay, now I was a little bit mean here because there is a function called numpy.repeat, or maybe it's called repmat. And this turns out to be not the best solution to this problem. In MATLAB, this is what you would use. You would use the MATLAB function repmat. But a better solution in Python is to use numpy.tile. And this is going to tile the matrix. And again, we need to specify the size of this matrix in a tuple in the second input here. So now let's print out C and see what that matrix looks like. Okay, so this is exactly what we want. And, you know, just to show you, maybe you did it slightly the wrong way. If you would have just said 3, then it kind of does, you know, it does something. It does reproduce it 3 times, but this is not exactly what we want. We want 3 by 1, so you need to specify both of these sizes in here. Okay, so that's C, and then finally we get to our matrix B, and that is going to be C times V. And then let's see, I'll print these guys out as well. Now you already know that it's not going to be quite this simple because we are broadcasting column-wise, and broadcasting column-wise is the less simple version compared to broadcasting row-wise. So we do get this error here, and the solution is pretty much exactly the same as I showed you several minutes ago. So I'm going to reshape this, so numpy.reshape. Oh, I guess you could have also gone back and changed the way that this V matrix is created to make this be a matrix with orientation, a vector with column orientation. But I'm going to reshape this to be A, 9 by 1 vector. And then I believe it's going to work. Let's see. Okay, then it works. We get the right solution. And then just to add one more thing here, instead of hard coding this to 9, I'm going to say length v. So what we've done here is take our vector v, which doesn't have any intrinsic orientation, and I've reshaped it to be itself into a 9 by 1 vector. And this 1 here is important. This now gives us a vector with a specific orientation, because this is now a two-dimensional vector. So Python is now thinking about this object as like a matrix where the number of elements in one of the dimensions is 1. And I think I will just finally print out, let's call it W here. I just want to make sure that this is really clear. So I'm going to say print w.shape and print v.shape. And then we can have a look at these things at the end. So here, vector w, after using the reshape function, is 9 by 1. And the original vector was just a 9-element array.